In this video, we're going to look at how we can link azimuth and hour angle. Let's start by reminding ourselves what azimuth is. Azimuth is a part of the horizontal coordinate system, and it lets an observer know which compass direction to look at to observe a star. It's based on a 360-degree circle, with the start point being north. As this is the start point, we define this as 0 degrees. We can then go around the ordinal points. So to get to east, we have to turn a quarter of the way around the circle, or a 90-degree angle. East therefore has an azimuth of 90 degrees. We can then see that the remaining points, south, halfway around the circle, will have a value of 180 degrees, and then west has a value of 270 degrees. Now let's put this into a scenario and imagine that you're looking towards the southern skies at night to observe the stars. In this example, a star has an hour angle of 1 hour and 30 minutes. Because it's positive, it means that the star has passed the observer's meridian, due south 1 hour and 30 minutes ago. We therefore know that it's 1 hour and 30 minutes to the west of the southern meridian. However, to give an overall value for azimuth, we need to convert this into degrees. To make the maths easier, we're going to convert our values of time into minutes. We know that 1 hour and 30 minutes is 90 minutes, as an hour contains 60 minutes, and adding on the remaining 30 minutes gives us 90. We also know that 24 hours is equal to 24 multiplied by 60 minutes, which is 1,440 minutes. Now, we know that the stars will move through 360 degrees in approximately 24 hours, or 1,440 minutes. We're not using 23 hours and 56 minutes just to make the maths a little bit easier. So therefore, using ratios, we can convert this to find out what 90 minutes is in degrees. To go from 1,440 minutes to 90, we divide by 16. And we need to do this to both sides. 360 degrees divided by 16 gives us 22.5. Therefore, we know that the star is 22.5 degrees west of the southern meridian. Remembering that the southern meridian has an azimuth of 180 degrees, we can then add this onto our 22.5. And this gives the approximate azimuth of the star as 202.5 degrees. We can also tackle this question in reverse. In this example, we have a star with an azimuth of 184 degrees, and we want to calculate the approximate hour angle of this star. In other words, we're trying to calculate how long ago it was when it was on the southern meridian. Well, we can see that if it's at 184 degrees now, then it has travelled 4 degrees further west than the southern meridian. So going back to our previous calculation, we know that 24 hours is the same as 1,440 minutes. And we can use our ratios to work out how many minutes is the equivalent to 4 degrees. So to get from 360 to 4 degrees, we have to divide by 90. And we need to do the same to both sides. So 1,440 minutes divided by 90 gives 16 minutes. Therefore, we know that the star has travelled for 16 minutes since it was on the southern meridian, and so it has an hour angle of 0 hours and 16 minutes. It's positive because it's already passed the southern meridian by travelling west.